What's going on, guys? My name is Al. I come back with another video, this time with a exploit development video with the software Kolibri, which is like a web server software that had a buffer overflow vulnerability in the header. And what makes me want to do a video on this is that it has the concept of egg hunting, and I feel like it'd be a good tutorial to make on going through the exploitation process and the egg hunting process. If you don't know what egg hunting is, I'll quickly explain it. It's basically used to search memory for a specific tag that is set before shellcode. So whenever if it finds that tag in memory, it can execute that shellcode. Since the issue with this is we don't have actually enough buffer space to put our own shellcode in there, but we can do a short jump, -50, to basically allocate a little bit of space for us to put our egg hunter in there that will search for that. So it may sound confusing if you're not aware of it, if I'm just sitting here explaining it, so I'm just going to show you. So I'm just going to do a simple fuzzing program. In the beginning, it's just going to be the usual buffer overflow routine. So do 600 and attach it so we can actually make sure it has a buffer overflow. And you see the EIP's been overwritten, so we do indeed have a buffer overflow. So I'm going to find the offset. I'm going to use the Metasploit tools for this. Just pattern. No, I think I went in the wrong place. Yeah, and it's pattern create. And we're just going to do 600. Going to replace junk with this. Okay, now we're just going to send it. This will help us get an offset. Okay, just the address I got to write down. I don't know why I did that. Copy and pasting is weird, or I'm just not used to it. We're putty. And our offset is 515. So now that we know the offset, we can do another test to see if we can actually, well, if it is the right offset, just in case. So I'm just going to do A's to 515, and then B's 4 bytes. And we can see if we actually have control over it doing that. And we do. See, this has been overwritten with B's. If we view the ESP, we can see, yeah. So we know we have control of the ESP, so I'm going to go ahead and find I'm going to use Mona to find a jump ESP and a DLL that we have access to. So I'm going to do this command, and immunity debuggers are weird, so it's going to do all this stuff. And let's see, this looks like a good one. And here we go. Need to copy that instruction. I'm just going to put it into my script just for reference. There we go. So now I'm going to replace it with, I'm going to be converting this to Little Endian, so it'd be basically backwards. And be, so yeah, I'm going to test to see if that jump ESP actually works. Guess I'm going to go through the routine of opening everything. And I'm going to search for that jump ESP and F2 for a breakpoint and start it. And we should see it hit that breakpoint. And it does. So we know the jump ESP works correctly. So now I'm going to, I guess, yeah, go ahead and establish the short jump -50. So you can either use a calculator for this, but I already know it from the top of my head. It's EBCE short jump -50, and this is going to give us 50 bytes to work with. Not enough to put shellcode in, but enough to put our egg hunter in, which is going to be a smaller size than our actual shellcode. So that's why we're doing that. And I'm going to go ahead and I should have did this earlier, but I guess I'll do it now. But I'm going to go ahead and generate our egg hunter to search for a specific tag. I'm just going to type Mona egg T, and the tag I guess will be R4 F4, and it gives us this, and we're going to have to put this before our jump ESP. So I'm going to go ahead and call this egg hunter. Make sure it copies and pastes correctly. There we go, we got our egg hunter. So I'm going to go and pull out the calculator for this part just to prevent human error. And I'm going to do 515 minus the size of the egg hunter, which is 32, and then 5 for padding. That's going to be 478. So I'm going to make that 478. Then we're going to add right here our egg hunter. Then we're going to add our 580s just for padding. And yeah, that should be good for the egg hunter. So now I'm going to basically set up our tagged shellcode. It's going to be in another part of memory. So to do that, I'm just going to rename this to stage 1 and then name this stage 2. And stage 2 is going to go into the user agent. And this is going to be the tag, which I set to R4, F4, R4, F4. Yeah, okay. And then I guess I'm going to put in my shellcode, which I should have done it this way instead, but whatever. For now, I'm just going to put it as a no operation, which is 90, and just put it by something random like 500. And that's going to go right here. Probably not the best structured, but yeah, it works. So yeah, okay. Well, I can keep that open. I got this other window open. Oh crap, I shouldn't have ran it. Well, I was going to run it anyway. I don't know why I did that, whatever. So, to test to make sure it works, I guess I'm going to put another breakpoint at the jump ESP. And then I'm going to execute it. So yeah, I did hit our breakpoint, so I'm going to do F8 to go, and you can see there it does our short jump, and goes back 50 bytes. Once it goes back those 50 bytes, it's eventually going to execute our egg hunter, which it is right now. And you see this is going to go through a continuous loop of searching through the memory range for our tagged shellcode. And I just don't want to keep sitting here and pressing it because it's not going to stop until it finds it. So yeah, and it looks like it did find it. So yeah, there's our no operations, which is where we set our shellcode, and it did execute it. So we know that works. So now we're actually going to go ahead and generate the payload. So I'm going to use MSF Venom to do this. I'm going to use the shell reverse TCP. And let's hope I typed that correctly. Okay, looks like I did. So our payload is 710, which should be good. I put 600 in, but shouldn't make a difference. Should have plenty of space. So I'm going to put in this. That is going to be our shellcode. So now I'm just going to go and get rid of this. Add it to buff. And I'm going to add a os.system for my netcat listener. You don't have to do this, but I'm just going to do it because why not? Automate the process. And start the program and see if we get a shell. Hopefully it works. And it does. Okay. That's always the biggest moment to see if it actually all comes together, and it does. So yep, that's how you basically write a egg hunter exploit for Kolibri. I'll have the download for the software that I did this with in the description. It's on ExploitDB. So yeah, hope you guys enjoyed the video and learned something, and goodbye.